Assalamu alaikum everyone. Today we are going to see adaptive restart hybrid genetic algorithm. Actually, we are going to see its code. But before this, I will be explaining that what it actually do. Its most important point is that it is very good for the problems or for the conditions situations where our algorithms usually stuck in local optima. This is the problem that we encounter with mostly, that our algorithms stuck in local optima. So this approach is very good in the sense that it it gives you global optimum, and it gets the algorithm out of local optimum. It is hybrid genetic algorithm. As in genetic algorithm, I have introduced local search, that's why it's hybrid now, and its adaptive restart means that the algorithm will restart again and again with the like best chromosomes of the previous generation. Like it will be keeping the best chromosomes of previous generation. For any technique, we apply this technique on some problem, okay, and we optimize that problem, and to check that whether our technique or algorithm is better enough to optimize that problem. So any problem can be used, any benchmark function can be used for this, but I'm using this benchmark function, and I will later explain that you can use any benchmark function for this code in this code. On the right side, you can see its plot, one of its plots. On the left, you can see its input domain, that what are what is the range of values for the variables, which is -10 to 10, and global minima, that this function is minimizing function and it will minimize at -1. Its global minimum or its global optimum is -1 for the variables value 0, 0, 0, and on the bottom you can see its mathematical expression. Let's discuss its flowchart so it will be easy for us to understand the code. As you can see, there are two loops, the outer loop and the inner loop. Let's first discuss the inner loop. In the inner loop, what's happening? There it has some population and it's doing crossover, mutation and local search on the population. After that, it will do the evaluation, or you can say it will find the fitness of the chromosomes. And on the basis of evaluation, on the basis of fitness, here some selection will happen. And then if the stopping criteria met, this inner loop will break. There are three conditions of stopping criteria here. There are three conditions. If any one of met, the inner loop will break. The number one is that if the number of defined generations met. Let's suppose if the number of generations are 20, if the number of 20 generations have been done, then it will stop. The number two is a time constraint for what amount of time this algorithm should run. And the third is if the error is below the tolerance that we have defined. Here comes the outer loop. And what happens in outer loop, that every time a population is generated randomly, plus in that population we concatenate the best chromosomes of the previous generation. So here, that's why it is known as adaptive restart hybrid genetic algorithm. Okay. And this generation is then passed to the inner loop where all of this happens. And the stopping criteria of outer loop is there are two conditions. The number one is if the number of defined generations has passed, and number two is the time constraint that we have defined. And at the end, we have some optimal solution and the best solution that we have after this. Now move towards the MATLAB and to see its implementation. Before going to MATLAB, as I said, there is going to be some objective function file in MATLAB where I have to define my function, like the minimum and the function that what is its mathematical expression and what it's going to return. So for this, I suggest this website. Here you can find all the benchmark function, and I liked it a lot because here is present every detail of all the benchmark functions. Okay. Now I have opened one of the benchmark function. Here is all the detail, the plots of this function, and here is its description and the input domain. That what are the range values? The range of values that can be for the variables are minus 32 to plus 32 for all the x. Okay, and it is a minimizing function as well, and it will minimize at minus 200 for the x value 0. And here is the MATLAB implementation. That what you need to do is, in my code you just need to copy this thing and paste it in the objective function file. Okay, it is actually the mathematical expression, and these are the required initial values to be evaluated, and this is the final score, the final fitness, which will be returned by this function. Now let's move towards MATLAB. Here, this is the objective function where I said you need to paste that the expression, mathematical expression, and y is the score, the fitness that is going to return for the chromosome for which the fitness is going to be calculated. Here's the population function that randomly population will be initialized. Then here is a crossover will be done, and then some mutation will happen, and then some local search will be done that in the neighborhood, if some chromosome is better than the present one, then it will replace it, otherwise no. Then evaluation means the fitness of the chromosomes is calculated, and after that, on the basis of this calculated fitness, some selection is done, and this is the main file where the whole of this code is running, where I'm calling all the functions. Okay, the parameters, the things that you need to change or which are problem specific are this lower bound value and the upper bound value, and if it is minimization function, then you need to specify here -1, or if it is maximizing, then you need to put here 1, and it's the computing time in seconds, that for how much time you want this algorithm to run, the time constraint actually. And these are the parameters which you can set by yourself, and which are not determined at first, that you come up with the best parameters with experimentation and hit and trial method. And these are the number of generations for which you want to run this algorithm. And now here we are calling the population function, and we are initializing our population. In that population, we concatenate here the best chromosomes of the previous generation. P1 stores the best chromosomes of the previous generation. Then crossover mutation and local search is done. After that, evaluation, these chromosomes are evaluated, and based on the fitness values, the selection is done. And at the end, you get your the best value for the function yet achieved, and for the chromosomes for which you have achieved this value. As the time constraint, the time I need to reduce this. Let's say 30 seconds, for 30 seconds. Let's run this code for 30 seconds. One more. From every generation, we are going to keep the best 3 chromosomes that we will pass to the next generation. So what will be the plot in the output? The plot will be the fitness value of the best 1 chromosome from 3 of them, and the average fitness of these 3 chromosomes. Here you can see the blue dot. The blue one is the fitness value of the best chromosome, and the red dot shows the average fitness value of the best 3 chromosomes. And you can see that they are approaching towards some negative value. And we know that our function is minimizing function, and it minimizes towards -1. Slowly and gradually, it's minimizing towards minus. As our time constraint, due to our time constraint, algorithm has stopped. Let's increase this time and run this again. Here you can see that here at this point, it was stuck, it may stuck if it was not genetic, and if it was not adaptive and restart, it may stuck here in local optimum. But because this algorithm has ability to get out of local optimum, it just jumped out of this optimum, and it's approaching towards -1. As we know that we haven't told this algorithm that we haven't told this algorithm that our problem is minimizing towards -1. Okay, it's finding this solution itself. Again, due to time constraint, it has stopped earlier. And even for this you can see that the objective, the best value that we have yet received is -0.8763, and for the chromosomes with values 0.000 and 0.112. Let's run this one more time for 70 seconds or 65 seconds. Again, this algorithm has the ability to get out of local optimum, which happened here, and it's approaching towards, right now it's at -0.8, and it's approaching towards -1. Slowly and gradually. And we are almost there. We are almost there. And here you can see that the best value achieved yet is -0.9730 for the chromosome, 0.000 and 0.0262. So guys, I hope you have got some idea about adaptive restart hybrid genetic algorithm, and it may help you out, and the code will be available in the link, and you can comment. I have also written a post for this, and its link will be given in the description. You can visit and comment there whatever if you have any questions, etc. Thank you.